Hello, everyone. Good evening. Dear authors and invited guests, welcome to the technical session 1A. Myself, Anjali, and this session will be moderated by me. On behalf of the Global Knowledge Research Foundation, it is my great pleasure to welcome you to the International Congress on Information and Communication Technology, ICICT 2023. London, UK. The eighth edition of the conference is being organized in a hybrid mode. The physical event was held in London, UK on 20th 21st February 2023, and the virtual event will be held through Zoom today and tomorrow, that is 22nd and 23rd February 2023. I hope you will enjoy the knowledgeable and interactive session throughout the day. In this session, we have 6 presentations, and each presentation will be given 12 minutes for the presentation and then 3 minutes for the question and answer round. On 10 minutes, I'll raise a gentle reminder for you to conclude your meeting. There is another request to all the participants that you please stay connected with us till the closing remarks. Also, if you have any query or just before we get started, I would like you all to introduce you to the chair of the session. Our first session chair is Professor Geeta Navle. Dr. Geeta Navle is working as a professor and head of 20 plus international and national conference and has 3 patents. So welcome you, ma'am, here at our conference.
Thank you. Thank you so much.
Now I would like to using smart meters and blockchain. The presenter may please start their presentation. I hope I'm audible.
Yes, Anjali, you are audible. You can announce the presenter name.
I guess I have already announced that I would like the presenter to please start their presentation.
Excuse me, can I start?
Yes, you can start, sir.
Thanks. But I want to capture my slide.
Yeah, sure.
I think.
Sure, yes.
Can you see?
Yes, we can.
Okay. So I start. So I present under the title, the decentralized renewable electricity certificate using smart meters and blockchain. This is my contents. First is introduction. Global warming in recent years has increased the demand for renewable energy sources that are good for the environment. And as a result, there is a need for a method to prove that the electricity used is generated from renewable energy sources. First, I will present a model for authentication of energy sources and the certificates necessary in such a system. And a power station sells the electricity to an electricity retailer. The power station then sends information about the generated electricity to the certificate issuing authority. And the retailer then requests the certificate from the authority. The authority issues their certificate based on the generation information. And the certificate user then purchased the electricity along with the certificate and used it. Next, we consider what threats can be assumed. One possibility, sorry. One possibility is the power station claim to be generating electricity from renewable energy sources, even though they are not, well, not entirely. Another threat is the electricity retailer rewrites the amount of electricity generated on the certificate. An authority obtains hidden inside information from retailers. And certificate user use the certificates they have purchased. So to summarize, we need the following to prevent these threats. First, mechanism to check authenticity of certificates. The second is decentralized issuance and management of certificate. The third is verification system to check the amount of electricity. The fourth is a method to trace the source of certificates. Next is fundamental technologies. The following is a brief description of the core technologies used in this model. Blockchains are characterized by their decentralized nature. It is also characterized by the inclusion of a hash value of previous block to increase tamper resistance. We adapted blockchain because we need some mechanism to decentralize the authority role. And smart meters are attached to distribution lines and can transmit real-time electricity information remotely. So smart meters can simplify the issuance of certificates, even for small-scale power generation, such as feed-in tariff generation. This is my proposed scheme. The proposed model roughly consists of first, sale and purchase of electricity, creation of certificates data. Second, verification and broadcasting of blocks containing certificates data. Third is receipt and use of certificates. The first step is sale and purchase of electricity. First, power plant P sells electricity to retailer R1. And second is smart meter transmits generated electricity data from the smart meter to some data pool. And next step is retailer R1 creates the certificate data on the purchased electricity and send it to representative retailer R2. And the representative retailer compiles the certificate data sent and creates a block and send it to the peer-to-peer network. And the peer-to-peer network compiles electricity retailers. The next section deals with verification and transmission of blocks containing certificates data. Verification is carried out by a representative. And if the verification result is correct, the block is transmitted to the retail company belonging to representative, and the recipients update the blockchain. And verification does two things. First is check whether the block generated is correct formally. And second, check whether the information in the block is correct based on the information in the data pool. And to I'm sorry. And verification requires an incentive. However, potentially electricity retailers can make more profit from selling certificates than from selling electricity normally. And next is to prevent double use. And to prevent double use, all information about the delivery is recorded on the blockchain. The delivery of certificates is agreed on a peer-to-peer network through electricity retailers. This diagram shows the passing of certificate A. The certificate data to be passed is sent to the representative, and the representative creates a new certificate B based on the received certificates data. The new certificates data is appended with the hash value of the delivered certificate. This diagram is here. The ownership of the new certificate now belongs to the person receiving the certificate. User can check with the marker root included in the block to see if the certificate they are using is correct. And finally, conclusion. Finally, to summarize this paper, the issuance and management of certificates is carried out in a decentralized manner using blockchain. The use of smart meters also simplifies the issuance and or of certificates for small-scale power generation, like feed-in tariff generation. However, incentives for peer-to-peer networks participants need to be discussed. In particular, proper incentives are needed to prevent, for example, 51% attacks and more. Thank you for and I'm done. Thank you for listening.
Yeah. Thank you, Yuki.
Thank you.
Yeah, Yuki.
Yeah.
Hello.
Hello. Yeah.
Yes. Are there any verification methods other than that which you have used? They are available.
Sorry. Pardon, please.
Are there any, you can say, verification methods are available?
Well, that's question is some verifications questions.
So what? Okay. Why you have chosen the verification method which you are using in your paper?
Okay, so first I want to make some decentralized this model some issue certificates or manage certificates. So and this is a very so just a moment, please.
Yeah, okay, thank you. Thank you, Yuki. Yeah.
I'm sorry.
Thank you so much. Yeah. Riddhi, over to you.
Okay, so we would like to move on to our next paper. I would like to ask our next presenter, Dr. Bala Alaji Salihu, to present their paper on energy-aware contention addressing algorithm in WLAN, Wake Up Radio Network Uplink. I would like to request the presenter to please start the presentation.
Okay. Thank you very much. Let me project my PowerPoint. You see my screen now?
Yes, we can. Yes, it is visible. Yes, yes, yes.
Yes,
sir.
it's visible.
Okay, thank you very much. Thank you. Energy aware contention address algorithm in WLAN wake up based radio network. Okay, this is my presentation outline from introduction, statement of the third problem of the references. Introduction. This is a typical WLAN network today with IoT, Internet of Things, personal area networks, PAN, wireless local area network, and many more. Use of Wi-Fi 802.11 is becoming more popular than ever for different purposes. We use it to interconnect with our many devices, from computers to tablet phones, little machines, even televisions, smartwatch, to mention but few. 802.11 legacy has a number of standards. It has undergone series of development. We have experienced series of development for 802.11 legacy, IEEE 802.11 legacy. So you can see from what I have from my figure 2, we have WLAN standard that spread to 802.11g, 11n, 11p, but aside 11g, 11n, and 11p, we have 802.11a.11b extending and having more standards on that. All these are result of changing one protocol or the other to make the performance of WLAN a better one. And the frequency band being used by this 802.11 ranges from 2.4 gigahertz, which is a free band license, 5 gigahertz, which is also a free band ISN band, and then 6 gigahertz and 60 gigahertz, especially for the 5G we're anticipating for deployment anytime soon. One of the commonest contention algorithms is carrier sense multiple access with collision avoidance. It is the communication technique adopted for WLAN standard with support for both centralized and ad hoc network. In this sense, every device within the network attempt to transmit, but before transmission, they have to sense the channel to make sure that the channel is free before sending their packet. So not sensing the channel and sending packet arbitrarily could lead to the loss of packets, thereby retransmitting, wasting energy, and then reducing the throughput. So typically, for every device in a network to transmit, it has to sense the channel, and if you notice the channel is busy, the device would have to back off. So any station that attempt to transmit, it has to back off if the channel is busy and wait for another time to attempt again to transmit. So the techniques adopted in overall power consumption reduction of stations. As stations contend for channel, they tend to lose energy. They use energy to continuously probe the channel, to sense the channel, to know either the channel is vacant for them to transmit. And that continuously actually affects the energy because of the energy consumption that is involved in attempting to send at every time. To sense the channel is actually a burden on devices, and therefore that will also reduce the latency. So this work, we look at reduction of the stations, is our consumption of power by the stations and improving the throughput and latency. Looking at it typically from this figure 4, this is a typical of the schematic of how a device, any wireless network device, especially 802.11, is that okay? Techniques. This is the WLAN algorithm when it comes to contention. You can see we have an AP, access point 1, A, B, and C. And we have the timeline. So at every point in time, when we have the time partitioned into slots. And each slot, every network device or station will attempt either to send or back off or be in a sleep mode. So what is the actually problem we want to solve? There are a number of contention-based algorithms that allows devices, network stations to contain for the channel. However, these traditional contention-based algorithms allow a single station to emerge at the end of the contention period. So many of the stations will go into contention, but at a time, it's only one that will be successful in transmitting. So all other that we are not successful would have wasted energy for that period. They have to come back again and recontend so that they can be able to transmit. So the increasing size of wireless network we have today, almost every now and then, new devices are being manufactured and be added to network in our places of work, in our industries, in the markets, and just mention a number of places that new devices are being introduced. So increasing size of wireless network therefore poses challenge of increasing energy consumption due to increased waiting time of stations and latency. Therefore, for us, we consider an algorithm that will allow a set of stations to win. Instead of one station winning, we'll have a number of stations winning during the contention period and permit all of these stations, all of these clusters that win during contention to transmit in a definite order. That will be better than allowing many to contend and one person will know. Many will contend, a cluster will win, and that cluster will be allowed to transmit, to use the channel in a definite order, in a defined order. So the STA waiting time is going to reduce the waiting time during contention, is going to save energy, and of course, it will reduce collision and improve throughput. So that is the primary aim of this work. And the aim of this work is to increase energy efficiency and reduce network latency for 802.11. Wake up radio. However, this work, we are only considering uplink. There are a number of works already on the downlink, but very few work in the uplink. And the objectives of this work include to design energy-aware contention addressing algorithm for energy efficiency and latency reduction in 802.11 wake-up radio in uplink. Compare the energy-aware contention addressing with existing algorithms and to evaluate the performance of the algorithm. And the scope, the research focuses on energy efficiency in the uplink of contention-based wake-up radio enabled in 802.11 by developing an algorithm. So, mind you, these algorithms are going to be implemented as part of the protocols for either the protocols to be implemented at the MAC layer for 802.11. The techniques, there are a number of techniques already, a number of techniques already proposed in the literature. However, there is still a gap because of the energy that is involved in so many of them. And a number of them include wake-up radio-based, carrier sense multiple access, we have broadcast-based wake-up control framework, backup freezing, wake-up radio-based, early sleep optimal, and threshold selection. These are just a few of them. This table summarizes a number of literature that we have reviewed that have really worked on energy contention, contention for channel. However, little or very little consideration is given to energy saving as well as throughput and latency during transmission. These are also a number of efforts that has been made. And you can see the TAN-S and Urbana has really been working in this area, and we have taken their work to benchmark with. Now, research methodology. Wake up radio-based early sleep optimal contention window. These algorithms by Turner have really performed. However, the backup algorithm and the broadcast-based wake-up control framework were evaluated. So we have models too for career
Hello, Bala.
Yes.
Hello. Yes, you
Yes.
have only 2 minutes, sir. You have only 2 minutes.
Okay, let me go back.
Yeah.
Let me go straight to my algorithm. So algorithm, this is the algorithm for the energy aware career, energy aware. We have actually hybridized, and these are our results. These are results showing how contention is going to be carried out by each station. Again, these are our results compared to other algorithms in existence. This is part of our result for latency. This is the result showing the energy efficiency. This is the result showing for the latency. It's waiting the latency for energy aware. And this is for the throughput compare with early sleep optimal contention. Conclusion, the aim of optimizing energy consumption and reducing the latency of the linear uplink without compromising the throughput was actually achieved. The hybrid contention addressing is actually, we call it hybrid because we combine the algorithm from different authors to really give us an energy efficient algorithm, offer 95% maximum energy consumption over the early sleep optimal contention. Maximum throughput increased by 16%, where the latency is kept approximately constant across the contention window at 9 milliseconds. Further research on this algorithm will need to include consideration for return transmission and downlink. Thank you. A hybrid contention addressing algorithm technique for channel access that help to reduce energy consumption in 802.11 has been developed. These are my references. Thank you for listening.
Thank you so
Okay,
much,
Bala.
Bala.
Yeah.
Yes.
It was nice presentation. Just
Thank
to,
you.
yeah. In the literature survey, you mentioned the problems which were addressed by the earlier authors, as well as
Yes.
you talked about, the approach they have used to solve the problem. Whether
Yes.
apart from that, are there any disadvantages of the literature review which you have reviewed?
Yes. What we have done.
And just highlight one disadvantage and whether you are going to work on that advantage or not.
Yes, many of those researches either consider energy alone and then at detriment of the throughput. Yes, you save energy, but the throughput would have been reduced, or the latency would have, you have affected the latency. But what we did now is we combine, we hybridize the algorithm, taking advantage so that the throughput is not going to be affected while the energy is going to be reduced. So, and also save time, thereby improving the latency.
Yeah, okay, thank you so much. Thank you.
Thank you. Thank you.
Okay, before moving on to the next presentation, I would like to request all the presenters will be highly obliged if you all can turn on your videos while presenting your presentation. Okay, moving on to the next presenter, I would like to request Zuzuna Spitalova to please present their paper on shared parking concept in the smart city environment. Dear presenter, please go on with the presentation.
Yeah, so let me share your screen, my screen. Okay, can you see my screen, please?
Yes, it's visible.
Okay, thank you. Yeah. So my name is Zuzana Špitalova, and I would like to present you our project, which is shared parking concept in the smart city environment. Firstly, I would like to introduce also my colleagues which were working on this project with me, which are Lucia Mandova and Martin Opatovsky. We are the students of Slovak University.
Sorry for the interruption, ma'am. But can you make the full screen?
So I'm not sharing.
Yes, it is okay then. Okay.
Now it's okay, yeah? Can you see that?
Yes, it's
Okay.
visible. You can carry on. No worries.
Okay, now it's okay?
Yes, it's all right.
Okay. Yeah, so we are the students of Slovak University of Technology of the Faculty of Informatics and Information Technology, and at our faculty there are various research groups. So we are the part of Automotive Innovation Lab. This Automotive Innovation Lab is dealing with the topics like vehicle to everything communication, IoT, smart cities, and many other topics which are related to some smart topics and some IoT communications. Firstly, I would like to go through the content of my presentation. So I start with the target of our work. Then I'm going to talk about the parts of our system. Then I'm going to go through some testing topics, and I finish my presentation with some future plans with our designed work. So, as I told, we are the part of the Automotive Innovation Lab, which is dealing with some smart topics. So, our project is based on the smart city, which is using the modern technologies for some conventional services. And because of that, we designed the system for sharing the parking places in the certain area. This system respects the good manners, and it's based on some green concept. This means that if I am an owner of some parking place, of if some company if some company owns some parking lots, so they can offer the parking places for other people using these apps when these places are free. So, for example, during some weekends, or if the owner is just one person, so during the hours which this place is not used, so this could be offered for other people in this community. And our app is designed for the smart environment. So this means that we just not offer this sharing of parking places, but our app enables also some data collection, which could be used for some future purposes. For example, if we see which kind of parking places are used a lot, so there could be also be some improvements in the city infrastructures. And respecting the green concept, this means that when you don't need to spend much time for finding your parking place, because when you use this app, so you can you can choose the parking place and to be navigated to this place. Our system consists of two parts, which is front-end and back-end part. For every part of this system, we defined some requirements which we wanted to achieve.
Hello, Zuzana. Sorry
Yeah.
to interrupt you, but your slides are not changing.
Okay, and which slide you see?
You are still on the introduction slide.
Okay, and now?
Yeah, it changed now. Content.
Okay, now the target of our work front-end application, yeah?
Yeah.
Yeah, okay. So there were some requirements defined for our front-end part of application. So we wanted to make it user-friendly with some fast responding and for many people. So this means we wanted to respect the multi-platform usage. For that or before the design, we made some overview of apps which are on the market. So for that, we were able to design the good menu or the good navigation for this application. We decided to use the React Native framework for the multi-platform usage. So also the users with Android and also with iOS can participate or can use this application. For the secure communication, we use HTTPS tokens, and the communication between front-end and back-end part is for that there is some Postman APIs used. We have also the target, which is modularity and open source characteristic. This is just for some future usage or future work of our system. Our application offers two roles, which is the user and the provider's role. The user is just the person which wants to find some parking place for himself, and the provider's role is for the person which owns some parking place or parking lots and can offer that for the people which can use that when these places are free. For both roles, the registration is needed, and there are some information which are required for the user and also for the provider's role. Here we can see some screens from our application. So at the first screen, we can see the offers for parking. Here is the screen. It's for when we want to delete our offer. Here we can see the screen with editing some offer for parking. So here we can put the address of the area in which we want to find some parking place. Here the availability with the days and the hours. And for example, there is also the possibility to put some number of the parking place if this place is in some parking lot. And on the fourth screen, we can see the calendar of reservations. At this slide here, we have some other screens. The first one is the map with selected parking places. The second screen is with the navigation menu. So it's like the whole page of our application, some new offer, like my offers as I can offer also the parking place. And if I want to use the both roles, we have the possibility to switch between the roles. So if I want to be the provider or the user. The third screen is for the profile. So if I create my account, so I have to put my name, email, and some other, maybe some other information about me. And on the fourth screen, we can see also the specification regarding to the parking place. So I can also specify if I'm interested in the place with some charger. For example, if I use the electric vehicle, so I need the charger, so I can specify this parking place. Or for example, if I'm interested in the outside or inside parking place, or if I want to use some family place. So we use more specifications for these parking places. For the communication between front-end and back-end part of our system, we use these Postman APIs. So we here is some example of the APIs which we use for that. And here we can go to the backend part of the application. So there were also some requirements defined for that. So it's very similar to the front-end application, and to achieve that, so fast responding, secure communication, or some scalability. So for that we use Django with PostgreSQL database. For secure communication we use JSON Web Tokens. Our backend runs in Linux-based containers, and we are also preparing the administration tool for maintaining the application, and we want to do our system open source, which was also the requirement, but it's the part of the future work with this system. Here we can see some logical model of the with the relations between tables in the database. So as you can see, for example, in the parking type, we have several information gained using this application. So for example, from the infrastructure point of view, we can see which kind of parking places are used a lot. For example, if there are parking places with charger, or some family parking places, and so on. Our application was also tested after each feature implementation, and the whole application or whole system was tested just 5 people. Now we started with the huge testing of these applications. So we have involved more people for that, and we would like to improve these apps. And also improving these apps, there is a possibility to gaining more data, which we would like to analyze. And for example, make some solution for example, these city infrastructure improvements. The other project which is planned to be done with this system is the implementation in the parking lot. So we would like to see the free parking places in the big lot, which are automatically sent. This information are automatically sent to our application, and they are visible in the app. So, and according to this, we would like to do some predictions, for example, for some power consumptions in the cases of places with chargers, for example. So these are the plans, and maybe the other plans is to make it open source, so not just test this application just in the certain community in our university world, but we would like to put this application in GitLab and share it with other people. So this is all from my side. Thank you for your attention. And if you have any questions, so feel free to ask.
Thank you so much, Suzanne.
Yeah, Suzanne.
Yeah.
Hello. Yeah.
Yeah.
How you have ensured that there will be secure communication?
Yeah, so we would like to, so there is a there are implemented these HTTPS tokens. So the token is generated during the sending the request. So when the token is not valid, there is an email sent to the user, and he has to log in again into this application. And and the other requests can be communicated between front end and backend again. But we would like to also improve that, maybe implementing some other algorithms, and we plan it in future work. Or maybe if we talk about some data storage, there is also there is also the part of our future work.
Yeah, okay. Thank you so much. Thank you.
You're welcome.
Thank you, Suzanne. We would like to move on to our next presenter. I would
Thank
like
you.
to request, thank you. I would like to request our next presenter, Raghav Sharma, to please present their paper on SROIR SST, Super Resolved Eyes in the Sky. Please go ahead.
Thank you, Dilip. I'm sharing my screen. Please let me know if it's visible. Okay, thank you for your presence. Hi everyone, this is Raghav Sharma and I am from ICICT Private Limited, India. And I am working in a field of AI in R&D team. And before we begin this presentation, let me explain why we called it SROIR SSD. SR means super resolved. OIR means object to image ratio. So we are using super resolve image in this object direction, and we are handling object to image ratio because we are handling the aerial images, and in this aerial images, the object to image ratio is very less. And then SSD is a object detector in the AI, and we have modified this object detector and develop a new object detector. We collectively called it SROIR SST. So this is outline, introduction, then challenges, then data set that we have used, methodology, result, and analysis. Okay, so introduction. In object detection, so object detection is a technique that can find in a particular or desired object in an image. So like here in this images, this is the aerial images taken from the BISDON 2018 dataset, and in this images you can see the object that we are seeing is from the front view. In general images or standard images, so all the object we seen is front view, but in the aerial images it is on top view. So it looks very different from the real world or from the standard images. So so we faced many challenges because all the object detector that introduced previously were designed for the front view images or the standard images, but we have to work on aerial images. So then we have to modify those object detector. So so we face many challenges, and we will discuss these challenges one by one. Okay, second thing is challenges that we face in lab or control environment could be very different when we try to deploy that solution on real world. And I come from the industry background, so I have tried to deploy this network for many clients. So we are going to discuss those challenges that we find in real world. So first is the scale and size of the object. So here in the top images you can see a child riding a horse. So this object covering around 70-80% of the image, but in the aerial images the object is very less. So we call object to image ratio is very less. Here we can see this green patches, so it hardly cover 0.1 or 1% of the whole area. And this red patches, this look like object, but it is not an object, it's false detection. So it's very difficult to differentiate between the object and the other things. Second challenge is number of objects. In aerial images, the number of object is very huge. Like in this image, we can this image contain thousands of cars in it, or in generally previously developed object detector can handle 50, 100, or you can say 200 objects. But if the object is very large, then those object detector will not work efficiently. Second thing is size and resolution of the images. So aerial images resolution can vary from 1K to 3K or more than that. And all the introduced object detector or previously developed object detector can handle hardly 1K image. So these challenges that we have found when we try to deploy this solution in real world. And so in this presentation, we will discuss how we have handled this kind of challenges. And to test our model, we have used 3 public data set. First is Wisdom 2018 and Wisdom 2019. So this data sets collected from China's different 14 cities from drone and object were in moving conditions. So there is a huge variation in background and objects, and also the elevation was also changing. So the scale variation is also there, and the number of classes in the data set is 12. Second data set is Stanford aerial pedestrian data set. So this data set collected from Stanford campus from 8 different places, and the camera was fixed and person was moving. So background variation is not there, but object scale is very, very less. And classes in this data set is 6. Okay, so this is the overall methodology of my network. So I will discuss this, and then we will discuss one by one each component. So suppose we have 1K cross 1K image, and so the object size of this image is less. To improve the object size, we are using patching. But patching, if we consider all patches, then it will increase the computational cost. And there is some patches which do not have any object, so it will not contribute in the accuracy, but it will increase the computational cost. So to make it lower computational cost, we are using selective patching. So patch which has which contain the object, we will select only those patch. And there is some patch who has no object, then we will discard that patch. And after the selective patching, suppose we patch this image and we got 5 patches, and then this patches will feed to the GAN network, super resolution GAN. So it will convert the low resolution image to the high resolution image, and then we will apply these images will fit to the object detector. So this object detector is a modified object detector, and in the end a fusion of results. So the result we are getting is in the form of patch, and then we will convert into for the whole image. Okay, now selective patching. So as we discussed, like here, so suppose in this area there is no object, so we will discard this kind of patch, and we will consider only this patch who is having some kind of object. And for this, we are using CNN sliding window. So it is a kind of network which will produce a heat map. Heat map which shows that there is object present or not. So it will not distinguish between different type of object, but if there is an object, it will show in the heat map, and with the help of that heat map, we will select the that particular patch. Okay, there is an object, then we can select this patch like this. Second, SR GAN. So after the patching, the patch will feed to the SR GAN. So SR GAN will try to convert those low resolution image into the high resolution image. So this is the overall idea of SR GAN. The low resolution image will feed to the generator. It will generate the super resolution image. this super image will be compared with high resolution image. And with the help of this this comparison, the discriminator will try to discriminate between two and generate a loss. And this loss will back propagate to train the generator and discriminator. And with the help of this whole process, the generator will try to generate an image which is similar to high resolution image. Okay, so this high resolution image will improve the image quality, and that will improve the object detector's accuracy. After the high resolution image, the image will fit to the object detector. So this is the original SSD, and we have modified it according to the aerial images. Because the original SSD contains the 6 layer, and the last layer is to detect the very high scale objects, like there is some object covering a whole image, or some covering a 40-50% of the image. But as in case of aerial images, we are pretty sure that this case will not occur. So we have removed these last two layers. So it does not does not contribute in the accuracy, but it has improved the speed of the object detector. And secondly, this object detector was designed to handle the front view images, which has high scale object. But in case of aerial images, we need to handle the low scale objects. So we have reduced the anchor size, which is used to detect the object. So we have reduced it to 0.2 to 0.05. So by this way, we have modified the object detector, and all these three network we have concatenated it and apply object detection. And here is the result. So this result on Wisdom 2018, and here I'm showing the result. So at each step, what is the accuracy or mean average precision. So we can say the mean average precision with patching, we were getting 0.257. Then we have used modified as SSD, that modification we have done. Then we got improvement from 0.257 to 0.31. And then we used sRGAN. It improved it from 0.31 to 0.86. So this shows that each step contributed well, and we got much higher accuracy. And this is the result on different data sets. So we have tried on 3 data sets: Wisdom 19, Wisdom 18, and Stanford data set. And this is the result without sRGAN and with sRGAN. And this is the final result: 0.94 on Stanford, 0.586 on Wisdom 18, and 0.413 on Wisdom 2019. And this is the comparison of our result with the other algorithms. So in Wisdom, in case of Wisdom 2018 and Stanford, we are the leaders, and we are getting 0.586 and 0.94, so highest. And in Wisdom 2019, we are in somewhere middle. Thank you. So this is the bibliography, that GAN network that we have used, SSD, the original SSD that we have modified, and this is the different data sets. Thank you.
Thank you, Raghav.
Yeah. Raghav.
Yes.
Yes. Is it the algorithm which you have worked only it will detect the objects such as vehicles only?
Sorry, can you please repeat?
The algorithm which you have developed, the algorithm which you have developed, will it detect only the objects such as vehicles only?
No, it's depend on us. Whatever whatever the desired object, we can set it number of objects like person, vehicles, or any security persons also. So any number of persons is depend on the our training, whatever we are trying to detect.
Okay. And the data set which you have used, from where you have taken this data set?
Okay, so based on 2018 and 2019, so there was open challenge. So we took data set from there, and Stanford University data set is
Is it
also.
are they available publicly?
Yes, they are available publicly. Anyone can use it.
Okay, okay, okay. Okay, thank you so much.
Okay, thank you.
Yeah.
Moving on to our next presenter, I would like to request Lian Kaibe to please present their paper on use of artificial intelligence in the digital marketing strategy of Latvian companies. Dear presenter, please go on.
Yep. Hello, everyone. I'm sharing my screen. Full screen. Yeah. So today I will talk about our research use of artificial intelligence in the digital marketing strategy of Latvian companies. And the definition of marketing and artificial intelligence is the development of artificial agents that given of the information they have about consumers, competitors, and the company suggest and or take marketing actions to achieve the best marketing outcome. And why it's important to research this use of artificial intelligence in marketing. Here you can see statistical data about enterprises with at least 10 people employed in European Union who are using artificial intelligence, and in Latvia it's only 2%, but on average in Europe it's 7%. And Latvia has lower result of all European Union countries. So it's, in my opinion, important to research how we can implement artificial intelligence in digital marketing strategy. So we used descriptive analysis, expert interviews, and survey of representatives of Latvian companies. And the importance of the benefits that artificial intelligence can bring to digital marketing, in opinion of Latvian companies' representatives, are possibilities to personalize offers for consumers, customer service availability, for example, chatbots, ability to get data analysis performed by AI, and the possibility to reduce the number of routine tasks. These are main benefits, in opinion of companies' representatives. Assessments of the benefits that artificial intelligence can bring to digital marketing by 5-point scale. The most important is possibility to target the audience more precisely, possibility to perform marketing activities faster, opportunity to increase revenue. But the lowest score is for benefit. Artificial intelligence doesn't make mistakes. It's an interesting aspect of this survey. And factors impeding the use of artificial intelligence in digital marketing, in opinion of companies' representatives, is there isn't enough data. AI requires large financial investments. Artificial intelligence solutions take a long time to implement. We lack knowledge about the benefits of artificial intelligence, and there is no need for such tool in the company. But I would like to mention that none of none of aspects received more than 50% of survey. Only 44% of representatives mentioned one statement. And next question about assessments of the shortcomings of artificial intelligence in digital marketing by 5-point scale. AI has high implementation costs. Artificial intelligence has high maintenance costs, and the return of AI tools is unknown. And AI needs to be monitored. And last question was about company representatives' assessments of supplementing the digital marketing strategy with artificial intelligence solution with the next 2 years. And this research was made last year, and 49% of company representatives were hard to say if they're willing to implement AI solutions in next 2 years in digital marketing strategy of their company. And the main conclusion of this research is companies in Latvia little use artificial intelligence. It's most often used in digital advertisements, for example, Facebook ads, virtual assistants, email services, and checking the content of communication. And it's difficult for company representatives to say if artificial intelligence will be used within the next 2 years. Companies use artificial intelligence in digital marketing because it's an opportunity to personalize offers, to provide customer service, to get data analysis, and to reduce the number of routine tasks. The availability of financial resources, lack of knowledge and understanding, and the lack of specialists and availability of data, partly are also the size of the market, hinder companies from using artificial intelligence in digital marketing. It's best for Latvian companies to invest in already developed tools. The development prospects of the use of artificial intelligence in digital marketing strategy of Latvian companies will be similar to the development elsewhere in the world. And the hypothesis is put forward in the research that the use of artificial intelligence in digital marketing strategy of Latvian companies is hindered by a low level awarenesses of available artificial intelligence solutions in digital marketing, and lack of financial resources is partly confirmed, as the experts believe that these factors impede the use of artificial intelligence, but company representatives highlight the lack of data, which is also noted by some experts, and the lack of financial resources. And some proposals and recommendations which came from this research for company managers, they should assess the possibilities of using artificial intelligence solutions in digital marketing strategy, because solutions with artificial intelligence have such many advantages, and company managers should promote the interests of company employees in latest technologies and the potential opportunities to integrate them into marketing to order to foster the development of company digital marketing strategy, both in interaction with consumers and in the development of the marketing team as well. Marketing managers, when planning to implement artificial intelligence solutions in digital marketing strategy, should discuss with the company digital marketing specialists the objectives and functions of implementation of the tools, so that the company employees are not afraid of losing their jobs. And also, marketing managers, when implementing artificial intelligence solutions, should pay attention to the aspects such as digital marketing objectives, available data, and the environment in which artificial intelligence learns, in order to reduce the threat of artificial intelligence in digital marketing operations. Digital marketing specialists should identify the possibilities to use opportunities provided by them, Google Ads and Facebook ad platforms in companies' digital marketing strategy. The Ministry of Education and Science of Latvia, together with Latvian high schools, should assess the possibility of creating an interdisciplinary study program. The aim of educating the specialty of artificial intelligence marketing and change management, because experts believe that there is lack of specialists in Latvia who are familiar with both marketing and artificial intelligence to be able to implement these solutions in the company, not only in digital marketing, but also in other fields. And for researchers and scientists, they should conduct additional research directly to the principles of digital marketing strategy development for Latvian companies and the influencing factors of strategy development. Thank you for your attention.
Yeah, Dini.
Thank you so much, Leah.
Yeah, yeah. Is it just a survey paper you are presenting?
Yes.
So, do you have any future plans?
With this research, no. We will focus on other aspects of AI in marketing.
So, have you heard about the right now the ChatGPT application which is available?
Yes, yes, of course.
Yes.
It's one of focus we are thinking about.
Yeah. Will it contribute in the digital marketing?
I think yes.
Okay. Okay. Thank you so much.
Thank you.
Thank you, Leah. Okay, everyone, I think we have all our presentations done. I would sincerely thank our authors for their excellent presentation and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for your support during this 8th version and the previous 7th version of the conference. We would be happy to have you in the 9th version in 2024. All the presenters would be getting the digital certificates through email within 2 working days. And further, all the papers have already forwarded to the Springer. The publication will be live within 6 months. So kindly please cooperate with the team of ICICT 2023. I would also like to thank our session chair, Geeta Navle ma'am, for chairing this session.
Thank you
We
so
have
much,
this token of
Anjali.
appreciation for her. On the behalf of the team ICICT 2023 and Global Knowledge Research Foundation and partners. Thank you so much, everyone, for your valuable presence. I would like to kindly request all of you to please turn on your cameras for a quick snapshot. Can you all please turn on your cameras for a snapshot? I will request all the presenters to please turn on their cameras. Thank you so much, everyone. Please take care and stay safe. Thank you so much.
Thank you.
Thank you so much, Anjali.